lesson 7.6, solving systems of linear inequalities. So we're back to the shading we did in the previous unit, even if you don't remember it. So how would we find the solution to these two equations? Now you might think, oh, two equations, two unknowns, I got to solve. Well, no. Now it's all graphing, and the answer has to be shown visually. So let's set up our graph over here. And for those that don't remember, how do we graph these? Well, we look at this, and we just write an equals in for the time being, and we graph that. Now, there's no greater than or less than, greater than or equal to here. So it's going to be a dotted line, so just don't forget that when we put it in. So we're down 2, down 1 over 1, and we're going to dot a line here. Now the equation is actually greater than. Greater means above. So I like to use these little arrows, because if I start shading now, it's going to get kind of messy. So the same thing here. Let's graph this one. That's up 6. Actually, I'm going to go with a different color here. And then it's up 3 over 1. Well, I can't go up 3 over 1, so I'll go down 3, left 1. 1, 2, 3, left 1, and this will be a solid line. And it's less than or equal, so we're going to shade on this side. So this one, I'm going to draw it in and then erase it, is shading here, and the blue one is shading here. And our answer is where the two overlap, so I'm going to get rid of all of it. So it's apparent it's over here in the mostly first quadrant, a little bit into the other 4 quadrants. And I am able to do that by looking at my arrows, and that can take a little practice for some people. So let's go with a yellow shade. It's a neat way to do this with your calculator if you haven't done it. And it'll actually shade them both, and then you look for the area that's got 2 types of shading, so it'll look something like this. So that's your answer. And that's it. Now, as you get to Algebra 2, you'll be very interested in what goes on at these corner points. So how would I find that if I wanted to? Well, then I would just, if I wanted that point, I would just solve 2 equations. And I can do it any way I want. I can do it graphing. It looks an awful lot like it's -2, 0. It is, actually. That does work. So I can do it by graphing, substitution, or elimination. I've got all 3 options. In this case, I'd probably use graphing because it's right there. And then check my points. So let's try another one. This one's a little trickier because we've got 3 equations. We've got our y and x equations, which everybody always forgets. They don't really need to forget, but they like to do it to make us math teachers go insane early. Gray hair and all that. Early retirement. Hopefully nothing like what happens at the postal office. No, I didn't just say that. Anyway, moving on. Let's graph the first one. We'll put this in blue. Y is greater than or equal to -1. Well, here's -1, a solid line, so come across. And greater than is up, so I'll put my little baby arrows here telling me to shade up. Let's put this one in green. X is greater than or equal to -2, and it's a dotted line, so we go to -2 and make a dotted line. Not perfect, but good enough. Coming across. I never put arrowheads on my dotted lines. I suppose you should. And go purple with this one. Unfortunately, we're not ready to graph it, so let's manipulate it a little bit. So up 2. I'm going to avoid screwing this up like the last time I did it. Solid line. We want less than. Less than is below the line, so less than. So it would appear to me, and I'll go with the yellow again, below the purple, above the blue, to the right of the green, it's this area in here. Gives us a nice, neat little area. Very rare that happens with these bigger problems. Usually you get a very messy area. And on rare occasion, you actually get no area at all, because it says to shade above one line and to the left of another, and they don't intersect at all. So you can have problems like that. Otherwise, some pretty straightforward problems. You might want to take a point out of the middle. In this case, I know 0, 0 is in there, and say y is greater than or equal to -1. Is 0 greater than -1? Yes. Is 0 greater than -2? Yes. 0 plus 0 is 0. Is 0 less than 4? Yes. Looks like we did it right. That's it. Good luck.